Okay, so this is going to be the practice enter the lesson for hydrates. This is day 3 and the last part of our unit before we take our quiz and our test. So here we go. So what a hydrate is really just a salt, like you see here, with water trapped inside of it. Okay, and so here's our salt and here's our water, and then this 10 is the amount of moles trapped inside of this water. Okay, and we use that 10, we write that 10 from our prefixes that you see up here. So just to jump into some examples, down here, what we're going to do is we're going to name the salt and then put the prefix in, and for the water we're going to say hydrate. So it should be, this first one should be strontium chloride, and then now we do this part. This should be, because 6 is hexa, this should be hexa hydrate. All right, for this one down here, this is sodium carbonate. So just normal ionic naming rules. The only addition is this part over here, and 10 is deca, so this will be deca hydrate. All right, and then the only little change, not change, is the thing that we need to remember is this: the Roman numerals still count, because this is manganese and it's a B block metal, a transition metal. This should be manganese, and then it's going to be 2 because that 2 gets crossed back up as the charge for manganese. Manganese 2 chloride tetrahydrate. Okay, and so I'll let you kind of do number 2 on your own to see if you can get it. So the next thing is we need to determine the molar mass of each one of these. Well, because I got some space up here, what we're going to do is really find the molar mass of that and then the molar mass of that and add them together. Okay, now one thing that you're going to want to remember is that water has a molar mass always of 18.016. So because we're going to find the molar mass of water in each one of these, it's good to remember so you don't have to recalculate that each time, grams. Okay, so we do need to find the molar mass of zinc sulfate. So I'll have zinc, and there's one of them. This is also a reminder of how to do molar mass. Sulfate, there is one of them, and oxygen, there are 4 of them. Well, oxygen, the atomic mass is 16. Sulfur from your periodic table is 32.06, and zinc, where are you? Zinc, 65.38. Right? So I multiply all of that. This is going to be 32.06, 65.38, and then I add all those together. So I have 14, 4, 7, 9, 9, 12, 129.44, right? But that's just for my salt. I also need to do it for my water. Well, there's the molar mass for my water. Well, the thing is, I have 7 of those waters. So what I need to do now is take 7 times the molar mass of one water, because there are 7 of them, and then I'm going to add it to my salt molar mass. So 7 times, if I do my calculator, 7 times 18.016, I get 126.112. Add those up, 2, 5, 5, 15, 5, 155, 255, 255.552. All right, and that's my entire molar mass for that. Okay, and that's how you do the rest of these. That's just the molar mass. The same process for all of these. You take find the molar mass of your salt, add it to your molar mass of the water. Your water's times by how many moles of that you have. Okay, and so another concept that you might need to remember is that this 6 is a mole count for water. Okay, so every time we have coefficients, so when we look at our equations, our chemical equations, every time we have a coefficient, that's also a mole count. Well, just like 6 is a mole count, so that's why we need to multiply that 6 by the molar mass of water, which is always that. Okay? So the second part is now we need to find this formula that's given to us here, and then write the name from a given molar mass. So we have this mass here that we just found up here that's given to us. Now we need to kind of go backwards and work to what is this formula going to be, and then name it as well. So knowing a few things like this, we can find what this N is going to be. So N is always going to equal an amount of moles in any equation that we do. That's going to be something that comes back up. So for these, what we need to do is saying, okay, well, if I know the total is going to be 170.49, and I know that this N times 18.016, remember that's the molar mass of one water, is added to the molar mass of this. So I need to find the molar mass of that, copper, and this is chlorine. There are 2 of them, there are 1 of them. This is 35.45. Copper is 63.55. I got these from the periodic table. So I put that in my calculator, and I have 63.55 plus 2 times 35.45. I get 134.45. Make sure I did that right. There we go. Okay, so now this is just simple algebra. What do I need to do to solve for my missing N? Because really what I'm looking for is that N count that they give us up here. So when I subtract to solve for N, 0.49 minus 134.45. So if I rewrite this out, now I have N times 16 equals 36.04. Right, and then I go 36.04 divided by 18.06 divided by 18.06. There we go. Divided by 18.016. That should be 0.16. I get 2.0004. So really, we're thinking that it's 2. So we just solved for N. So I'm going to put that 2 back in for my N. So it should be copper, because this is the formula. I need to have that dot there. And then now that N equals 2, NH2O. And this is going to be called copper. It's a B block metal, so this is copper 2 chloride dihydrate. Make sure you put the 8 there. There we go. Scoot it over. Hydrate. Okay, so that's how you do all of these. You're just finding the molar mass of each of your salts, adding it to this equation here, and then setting it equal to the given molar mass. And then you solve for N. That N will tell you what number to put there, and then that'll also tell you what prefix to use in your written out formula. Okay. On the back, it gets a little bit more involved. Okay. So what we have here is the percent of a salt and the percent composition of water. So we need to find the formulas and the names of the hydrates given from before, and this really comes from practice in our lab. So what we're going to say is do the percent to mass, mass to mole, divide by the smallest, and make whole part, right? Because we need to find the formulas for this stuff. So percent to mass is very easy. Just put 85.25, and this is barium chloride, barium, so it should be BaCl2. And then your water is going to be down here, H2O. I have 14.75 grams of that. Remember, we're just taking that percent and turning it to a gram, right? And then I need to, well, that's percent to mass. Now I need to turn both of these masses into a mole. which means the molar mass goes here, 18.016. Now I need to calculate for the molar mass of barium chloride. So I go to my periodic table. I have barium is 137.33. Oops. Get out of here. Clear. There we go. 137.33 plus there's 2 chlorine, so 35.45 times 2. So the molar mass is 208.23. That's going to give me 1 mole for each. So when I take 85.25 divided by 208.23, I should get 0.4094, and my water 14.75 divided 18.016. I get 0.7812. We can put 5. Not a big deal. So that's percent to mass. That's step 1. Mass to mole. So here's my mole. Now we divide by the smallest, right? Well, the smallest is this one, so 0.4094. That's going to equal 1. And when I divide that, so in my calculator, I can just say divided by that smaller 1.4094. I come out to get 1.9, so we're going to think of that as 2. Okay, and so what that is that's saying these are going to be my mole counts, my my coefficient counts. So that means I'm going to have BaCl2, because that 1 is that coefficient there, but we don't put 1s there. And this 2 goes for my water. So this 2 goes there, 2H2O. And so what I have, when I go to name it, this should be barium chloride dihydrate. Okay, and it's the same process for all of these. Now when you get down to this one, this is just going to be found in the formula. Okay, this is just going to be found in the formula. Okay, but it's the same process as what we did up here. I hope that helps.